this problem here, we have been given two functions, f of x and g of x, and one of them is linear, and when we graph it, we're going to see that it has a straight line, and then the other function is what we consider exponential, that it is rapidly increasing by a growth factor. So in this problem, we are going to take a look at these tables, complete them, and then graph the two functions to see how they compare. So to start, over on the left, we have f of x equal to 2x plus 1, and to fill in this table, we want to replace our x with these different values that we have been given. So first, we have x equal to negative 2, so we're going to have 2 times negative 2 plus 1. That gives us negative 4 plus 1, which is negative 3. Then we have negative 1 for x, so 2 times negative 1 plus 1. This ends up giving us negative 1. And then 0 for x, 2 times 0 plus 1. That gives us 1. And then 1 for x, 2 times 1 plus 1 gives us 2 plus 1, which is 3. And then lastly, 2 for x, we have 2 times 2 plus 1. 2 times 2 is 4, plus 1 gives us 5. So now we have 5 points that we can plot for this first function here, f of x. So we can put this on our graph. Our horizontal axis is x. Our vertical axis is our y, or f of x, for this function. And we have the points negative 2, negative 3. So we can go to negative 2 on the x-axis and negative 3 on the y-axis to plot our first point. And then we have negative 1, negative 1. We have 0, 1, 1, 3, and 2, 5. And we can see that these 5 points that we have are going all in the same direction, that these form a straight line for this function. And we could have known that as well, just from the format of the function. It is in our mx plus b style of writing a linear function. And with this, some of the things that we want to point out about this is what we consider our initial value. That would be where it is crossing the y-axis for our y-intercept. So when our x is 0, our y value is 1. And then the other important part with a linear function is what we call our slope. So that is our m, and in this case, that is our 2. And we can see that in the graph, that when we go over 1 on the x-axis, our y values are going up by 2. So there's this sort of plus 2 that is happening every time I go over on the x-axis by 1. Our next function that we want to look at here is our exponential function, where we have g of x equal to 3 to the x power. It is exponential because our variable x is in the exponent. So to start, we want to put in these different values of x into this function. And we want negative 2 for the first one. So we have 3 to the negative 2 power. And a couple different ways I could go about writing this. This would be 1 over 3 squared, which then I could say is 1 over 9. Whenever I have a negative exponent, I can take its reciprocal to get rid of the negative. The next one, we have negative 1 for x. So 3 to the negative 1. that gives us 1 over 3. And then we have 0 for x, 3 to the 0 power. And whenever I have an exponent that's just 0, it simplifies to being 1 because 3 to the 0 doesn't really do anything. And then we have 1 for x, so 3 to the first power, that's just 3. And then lastly, 3 to the second power gives us 9. So now, in this one, our initial value is still the same thing. It is our 1, where it's crossing the y-axis for this. But then our growth factor, that we can see from this table, it is what our y values are repeatedly being multiplied by. That to go from 1/9 to 1/3, we have to multiply by 3. To go from 1/3 to 1, we're multiplying by 3. To go from 1 to 3, we're multiplying by 3 again. And going from 3 to 9, I multiply by 3 again. That I am consistently multiplying by 3 every time my x increases by 1. So that is what we would consider the growth factor for this exponential model. And to now take this and plot this a little bit on our graph here, if we plot this one maybe in red, then we're going to have -2 1/9. So it's going to be hard to put this on the graph, but we're just going to be very close to the x-axis at -2. Then we're going to have -1 1/3. And then 0 1. We'll then have 1 3. And then lastly, we have 2 9. And now looking at these 5 points, we can sort of see the shape that is happening here. If we try to connect them together as best we can, it gives this graph that we have forming here for our exponential model, 3 to the x power. And now a little bit to compare with these for these graphs. Both of these two functions, the linear and exponential function, went through 2 of the same points. They went through that y-intercept spot 0 1, and then they also went through this point 1 3. However, for between these two functions, our linear one, we're looking at the slope. So I'm looking at what I have to add to get to that second point that we had to add 2 with that slope. Our exponential model, we are instead thinking about what do we have to multiply by to get to that second point. So when my y value was 1 at the y-intercept, I have to multiply it by 3 to get to that second point. That is in that growth factor that's happening with these. That if we go from this second point here at 1 3, we're going to have to multiply that y value by 3 to get up to that next y value of 9. So we are just repeatedly multiplying by the same number. And that's the most basic explanation that we have for our exponential models, that we are repeatedly multiplying by the same value, and that value is our growth or decay if it's decaying factor.